Okay. Now you are already familiar with the navigation subject beta, and also you have already done quite a few online classes, so you are already familiar with the conduct of the classes. But still, I will just give you a brief intro of some important points. One, it is always recommended to join these classes on a bigger screen on a laptop or desktop. Avoid using mobile phones. The screen will be smaller and you will not be able to catch up. And in case during the video or during the lecture, during the session, you feel that your video has frozen, the video is not moving, slides are not moving, or voice is not coming, most probably it's a connection problem at your end. So then the easiest way to counter this is you log out from the meeting and then you log in again. So this logging out and logging in will rectify the issue and the video will continue. In case I have a issue on my side and my video freezes, I will come to know and I'll take a remedial action. If I get disconnected, okay, if I get disconnected, beta, can you mute your mics, Raveen? Thank you. If I get disconnected at any time, beta, during the session, during the class, wait for a couple of minutes. I should be able to join back. In a couple of minutes, I should be able to join back. In case I am not able to join, the problem lingers on and I am not able to join at all, then I will communicate with you on the WhatsApp group. I will tell you that I am not able to join and I'll give you further instruction on the WhatsApp group. So if I get disconnected, wait for a couple of minutes. I will be joining back. If not joining, then you will get a feedback on the WhatsApp group. Another thing, you can keep your videos off. It gives us more broadband available to us and it gives a better connectivity. I will be able to connect better with you. My video obviously will be on, so my audio and video will reach better. Another important thing is use a single device. Don't use two devices. So using two devices will create issues. So they will have interaction with each other. So that will create issues. When I'm explaining something, keep your mics muted during the explanation. And if you come across any doubts, whatever I'm explaining, just note it down. Note down your doubts, whatever doubts you have. After every topic or after every slide, I will take a pause, I will give a small gap, and I will wait for your doubts. I will ask for your doubts. So that time you can bring all your doubts. You can raise your hands, you can bring all your doubts, and then we will cover all the doubts in that particular topic, and then only we will move forward. So after every slide, after every topic, I will be taking a pause, clearing all your doubts, and then only we will be proceeding ahead. So these are some general guidelines, instructions which we are going to follow. Now, when I'm explaining a topic, explaining a slide, many a times I'll be asking your feedback. Is it clear? Have you understood it? So you can see a react button on top of the Microsoft app. So top में जहाँ आपको buttons दिखाई दे रहे हैं वहाँ पे आपको एक react button दिखेगा. So in that react button you can just press on the thumbs up button. So that tells me that things are understood and I can proceed ahead. It gives me a feedback that everything is going on fine. If I don't get any feedback from you, then I don't know whether you have understood it or not. Shall I repeat it? So a little feedback from you will give me the green light to go ahead. Okay, all right. So this was a basic introduction about the class beta. Any doubts in these?
No, sir.
Yeah. Okay, beta. Great. So great, beta. Very good. I believe all the people have joined in. So what I am going to do now is I am going to show you the examination format first and show you what all topics are there in our CellNav portion and how in what sequence are we going to cover them. So let's go. I'll be sharing my screen now. Okay, beta, I hope you can see the screen now. Examination format for navigation.
Yes, sir.
Yes, sir.
Very good, beta. Great. So in this navigation paper, beta, you see we have a 3 hours paper. Total marks are 200 marks and passing percentage is 70%. So you need 140 marks for passing. Now the paper is divided into three parts: part A, part B, and part C. Now in part A and part B, all the questions are compulsory. All the parts A, B, and C have 3 questions each. And in part A and part B, all the questions are compulsory. You have to attempt all the questions. In part C, you have a choice. Out of the 3 questions which are given in the paper, you have to answer any 2 questions. So total there are 8 questions, 3 in part A, 3 in part B, 2 questions in part C, which you are attempting. All the questions are for 25 marks. So 25 aids are totals up to the total 200 marks. The chart work paper will obviously be based on a particular chart, so that chart number will be mentioned here. Celestial navigation portion questions will be based on 1992 Nautical Almanac. You will be provided with a deviation card which you will require in chart work for converting compass bearing to true bearings. Variation is provided in the question paper. The speed of the ship is given. Height of eye of the observer is also given. And if these things are not provided in the question, you pick these things from the notes and use them. Also, the position of the landmarks, this is for chart work. Approximate latitude and longitude of the landmarks are provided to you. So you are able to easily identify the objects on the chart and carry on solving your question. Luminous range diagram is also given to provide you with the PLR to get the PLR of the lights. This is also for chart work. Now part A is entirely chart work. This you have already started. This is already going on. Now part B and part C both correspond to celestial navigation. The first question in part B, that is question number 4, is based on great circle sailing and composite sailing. So this question will be based on one of these 2 topics: great circle sailing and composite sailing. Question number 5 will be on simultaneous observation or staggered observation. This is also known as plotting of sights or graphical combination of sights. Now this plotting of sights or graphical combination of sights you have done during second mates also. This is also there in phase 1 now with a advanced inclusion of more topics. Then question number 6 is based on determining the position line by a celestial observation. It will have 2 parts, part A and part B. So there will be basically 2 sites which need to be solved. This question number 6 is based on site solving methods like meridian altitude, latitude by meridian altitude, longitude by chronometer, intercept, X meridian, and Polaris or pole star observation. So from these 5 topics, you will have 2 workings of position lines usually in this question. That will be question number 6. Then in part C of our paper, question number 7 is on a topic star suitable for observation. This will involve the concepts of stellar magnitude, the concepts of twilight, rising, setting, and twilight concepts. And this question could be based on another topic, which is star identification. So any of these 2 topics could be there in number 7. Then question number 8 and question number 9 are from principles of navigation. They could be based on different topics like twilights. They could be based on Kepler's laws of planetary motion. They could be based on the rational horizon diagram or the circumpolar bodies or the PZX triangle. Or you could have a question based on chart projections mnemonic projections, Mercator projections, how to make a chart of a particular area, or different questions related to the scale of the chart. So these are the topics on which our celestial navigation questions are based on. Now we will be going in the exact same sequence as you see here in the question paper. The first topic which we are going to pick up is the great circle and composite sailing. So this will be our first question. After this, we will move into site solving, all the 5 site solving methods, Marpas, Long by Cron, Intercept, X Meridian, Polaris. And based on these sites, you have simultaneous and staggered observation. So these will be the next topics which we will be covering up. After this, the next topic is going to be stars suitable for observation as well as star identification. And in the end, we will be doing the rational horizon numericals, PZX triangles, circumpolar bodies, and questions based on Kepler's laws of planetary motion or chart projections or twilight. So this is the sequence which I am going to follow. So you have the exam format as well as the sequence in front of you now, beta. Any doubts coming in your mind related to any of the topics or the format or the sequence, please go ahead.
So question number 7, regarding star identification, what all they can ask? Like, can you tell me one more time?
Okay, beta. I'll give you an example. A simple question could be, they may give you that on a particular day at a particular position, you sighted a star. This was the altitude of the star and this was the bearing of the star. This is the information what we obtain on board. So they will tell you that identify which star is this. A star was on a bearing of 030 at an altitude of 45 degrees for a observer which was in a position of 30 degree north, 70 degrees east. Identify the star. This could be a simple question for star identification.
Okay, sir.
Okay. Okay. और बताओ बेटा और doubts?
Sir,
Yeah, go ahead.
this as described big. How to allocate the time for the question, sir? Or is it good that we attend part B, part C, and finally give space for chart work? Or how do we go about this paper, sir?
Okay, beta. Let's keep this question for the end. Towards the end of the course, I will be telling you some examination techniques. So we will attend this question कि कैसे attempt करेंगे, कौन से part को पहले attempt करना है, कौन से part को बाद में. मैं एक brief summary आपको दे देता हूँ. Whichever portion you feel comfortable, that should be attempted first. This is a general guideline. Okay, but it is not hard and fast कि हमेशा ऐसे ही करना है. If you do this, this will be helpful. We will discuss in detail towards the end of our syllabus, beta.
Okay, sir.
Okay, and
Sir,
regarding time management, अभी के लिए बेटा जब आप शुरू में questions को समझोगे, when you understand the concepts, don't worry too much about the time portion. First, the emphasis, the importance should be given to understanding the concept and getting the right answers. Once you start getting the right answers, then speed can be picked up. The more you practice, the more speed you will be able to pick up. And roughly, to give you an idea, we should be able to complete a question within 20 minutes. हमारे पास जो टाइम पीरियड है बेटा, हमारा टारगेट ये होना चाहिए कि 20 मिनट के अंदर अंदर हम एक सवाल को सॉल्व कर लें. But as I told you, do not worry too much about the timing in the beginning. In the beginning, the emphasis should be on understanding the concept and getting the answers. Right, beta? Understood?
Sir, my query is regarding this question number 8.
Yeah. Go
This about the portion for PZX triangle, sir. Is it
Right.
possible to this portion should be covered before, because this PZX is using many places for calculations and all. Everywhere involved this to solve PZX triangle. So related to this, I request if possible this topic should be
Okay.
covered earlier.
Don't worry, beta. Relax. You will have sufficient time to practice it. Okay. ये मैंने लास्ट में इसीलिए रखा है, दिस सीक्वेंस हैज बीन डिजाइंड विद ए पर्टिकुलर अप्रोच इन माइंड, एंड इफ यू गो दिस वे, देखो अगर आप PZX ट्राइंगल करोगे ना, सॉल्विंग द PZX ट्राइंगल यू नीड स्फेरिकल ट्रिग्नोमेट्री, कोसाइन फार्मूला एंड नेपियर रूल। तो जब तक वो नहीं होगा तब तक PZX होगा नहीं बेटा, राइट?
ओके सर।
और PZX ट्राइंगल में जो आपकी साइड्स आएंगी, ZX साइड आएगी, PZ आएगी या PX आएगी, दे विल इन्वॉल्व द कॉन्सेप्ट ऑफ साइड्स। ओके, एल्टीट्यूड लोगे तभी तो जेनिथ डिस्टेंस आएगा, तभी ट्रू ऑल्टीट्यूड आएगा, तभी PZX ट्राइंगल बनेगी। सो दैट्स व्हाई यू नीड द साइड सॉल्विंग कॉन्सेप्ट्स फर्स्ट इन प्लेस।
I
ओके,
tried so many times. I learned these formulas and all, then concept. Then still this PZX need to be more clarification. I
नो
studied so many times, this theoretical and all, but when we are going to solve the question, then again stuck with some portions. It's need more
ओके,
practice and more clarification. That is the reason I request, if possible, this concept if clear, then we can proceed for further. Or but anyway, sir, what is my issue? I told you, sir. Rest up to you, sir. As per
नो
your
प्रॉब्लम
schedule.
बेटा। हाँ, बिकॉज आपको उसके लिए कुछ बेसिक्स की ज़रूरत पड़ेगी, सो वो बेसिक आपके माइंड में पहले डालने पड़ेंगे। एंड PZX पे जब हम जाएंगे, आई अंडरस्टूड योर प्रॉब्लम, आई विल गिव यू ए टेक्निक, ए मास्टर की विद विच ऑल द PZX ट्राइंगल क्वेश्चंस कैन बी सॉर्टेड आउट। ओके,
Yes.
सो इट्स नॉट दैट द क्वेश्चन उठाया और हमने उसको करना शुरू कर दिया। वी विल फॉलो ए पर्टिकुलर कॉन्सेप्ट, ए पर्टिकुलर टेक्निक विच विल अप्लाई टू ऑल द क्वेश्चंस।
Okay, sir. Yes, sir. Thank you.
ओके, ग्रेट। और बताओ बेटा, और डाउट्स?
सर ये फिफ्थ क्वेश्चन में आपने कुछ बोला था सर, साइमल्टेनियस एंड स्टैगर्ड ऑब्जर्वेशन के अंडर कुछ तो आपने बोला कि 4-5 आएंगे, क्या था सर वो?
राइट बेटा, बेटा लैटिट्यूड बाय मेरिडियन ऑल्टीट्यूड मरपास, लॉन्जिट्यूड बाय क्रोनोमीटर, एक्स मेरिडियन,
वो तो
पोल्स,
6
दोज आर द साइड सॉल्विंग मेथड्स। साइमल्टेनियस और स्टैगर्ड में जो टॉपिक अब एड ऑन हो गए हैं बेटा, सी द बेसिक प्लॉटिंग यू हैड डन इन सेकंड मेट्स आल्सो, बट कुछ एक कॉन्सेप्ट्स हैं जो अब फेज 1 में एड ऑन हो गए हैं, लाइक यू हैव द कॉन्सेप्ट ऑफ रिजॉल्विंग ए कॉक्ड हैट। ओके, और you may have a high altitude observation. A high altitude observation will give you a position circle, so that may be there in the simultaneous and staggered observation question, and you may need to use that concept. Okay, they may tell you to find the index error of the sextant when a cocked hat is formed, so that's a new concept. In some question, somewhere or the other, though it is rare now, they may give you a concept of back angle. Okay, so another thing which can come in these plotting questions is they may give the questions based on fundamentals of sites. Okay, like a site was calculated using one dr, then the site was calculated using another dr, find the azimuth of the body, something like that. So ये सारे concept जो है वो अब add on हो जाएंगे, which is over and above the second bits.
राइट सर, थैंक यू सर।
Okay, all right. और बताओ बेटा, और doubts?
Sir, only small request, sir. I have zero knowledge in Hindi, sir.
Okay, no problem. Were you able to understand up to here, beta?
Yes, sir. No problem.
Okay, all right. No problem. We will go in English. Okay, great. So everything looks well set. The doubts are sorted out. So beta, go
sorry,
ahead.
sir. Excuse me, sir.
Go
So
ahead.
one more thing regarding, is there any these part C? Sometimes they have, I think, some questions which are just short notes or something like that. So we'll get something regarding that, some material to study from. With
Okay,
us.
beta. Okay. Now, most of these part C questions are basically picked up directly from the book. Most of them. So मैं क्या करूँगा जब हम पार्ट सी की तरफ जाएंगे, आफ्टर वी हैव कवर्ड द बेसिक्स, so I will give you a list of probable questions, and most of them are there in the book, so I will tell you where they are. I will indicate in which part of the book, Principles of Navigation book, they are there, and I'll give you time to go through those topics. अगर उनमें आपको कोई डाउट आता है, we will discuss that in the class. And उनको छोड़ के अगर कोई क्वेश्चंस ऐसे आते हैं which are not there in the book, so once you start going into the past papers and you pick up those questions and you are unable to answer them, you can share it with me, post it on the group, and we will discuss them.
Okay, sir. Thank you. Copy that.
Okay. Okay, beta. Great. So all set, beta. चलें आगे. Shall we start off our first topic?
Yes, sir. Yes, sir.
Okay, great, beta. Very good. So, as I told you, first of all, I am going into the basics of spherical trigonometry. So, in basics में क्या आएगा बेटा? These are the basics of what is a great circle, what is a small circle, what is a spherical triangle. ये तीन चीजें पहले करेंगे. And once we do these three, then we will see what is the cosine formula and what are the Napier's rules. ये जो cosine formula और Napier rules हैं, these are used in great circle sailing, composite sailing. Not only there, they will again be used when you go into the PZX questions. The same spherical trigonometry concepts will be used there also. So let's go into it. Let me set up the presentation. Has somebody connected with two devices, beta? So if that is so, you can switch on to one. Okay, beta, great. So I hope you can see the great circle, small circle slide, spherical trigonometry slide. Okay, all right. So first of all, we are going into what is a great circle, what is a small circle, and what is a spherical triangle. So first we go into the concept of a great circle and a small circle. We have the diagram on the screen now. Now this is the diagram of a sphere. You can consider this sphere as the earth. The points at the top and bottom represent the two poles. You can see the North Pole where the pointer is right now, and the bottommost point you can see the South Pole, and exactly midway between them, this dotted line which you see is the equator. Now on a sphere or on the surface of Earth, a great circle is a circle on a sphere or on the surface of Earth whose plane passes through the center of the sphere. The great circle has the same diameter as the diameter of the sphere itself. The purple color circle which we see in the diagram is a great circle. So you see this purple color circle which we have in the diagram is a great circle because its plane, the plane of this purple circle, passes through the center of the sphere. The center of the sphere is represented by point C, So we can see that the plane of this circle passes through the center of the sphere. So this is a great circle. Now you can see the diameter or the radius of this great circle is going to be the same as the diameter and radius of the sphere. They will be exactly the same. Now, why is it called a great circle? Because this is the biggest diameter circle which we can draw or have on the surface of that particular sphere. It is not possible to draw a circle having a diameter greater than this that should lie on the sphere. So that is why it is called as a great circle. Now, as we have seen, the center of a great circle matches with the center of the sphere. To give you an example of a great circle, we have the equator on the surface of Earth. You can see the equator as a dotted line represented here in the diagram. So equator is a great circle. The plane of the equator passes through the center of the Earth, as well as the center of the equator is the same as the center of Earth. It is the biggest diameter circle which we can draw on the surface of Earth. So equator is a great circle. Also, like equator, all the meridians running from North Pole to the South Pole, all the meridians are great circles, or you can say parts of great circle. Now, a meridian and its anti-meridian or inferior meridian combined together forms a complete great circle. Like say, for example, if you consider the Greenwich meridian and the 180-degree meridian, if you join them together, it forms a complete great circle on the surface of the Earth. Now, we can only draw one and only one great circle passing from any 2 points on the surface of Earth. If you have two particular positions, two particular points on the surface of a sphere or Earth, there is only one and one great circle which passes through them. Now, there is one exception to this principle, this statement, this fundamental, and that is if these points are diametrically opposite. If these points are diametrically opposite, then we can have an infinite number of great circles passing through them. Like you have in the case of poles. The poles are diametrically opposite, so there can be infinite number of great circles that can pass. As an example, all the meridians 0 to 180 degree east and west are all great circles, and they are all passing from these 2 points, that is the North Pole and the South Pole. So 2 points which are diametrically opposite, infinite number of great circles can pass through them. And if we have 2 points or 2 positions which are not diametrically opposite, there will be one and only one great circle which will pass from both those points. Beta, any doubts in this up to here?
No, sir.
Very good, Beta. Great. Moving ahead. Now, moving on to the concept of a small circle. A small circle is a circle on the surface of a sphere not pass from the center of the sphere. Like say, for example, the blue color circle which we see in the diagram, this one, this is a small circle because you can see the plane of this particular circle does not pass from the center of the sphere which is at point C. So all these circles whose plane does not pass from the center of the sphere are called as small circles. the diameter or the radius of the small circle will be less than the diameter of the sphere. And the center of a small circle is not the center of the sphere. We know their centers are not matching. The centers of the blue small circle is here at this particular point, whereas the center of the sphere or the earth is at point C here. Now all the parallels of latitude except the equator are small circles. Whether it is 10 degrees, 20, 30, 40, 50, north or south, all these parallels on the surface of earth represent small circles because their plane does not pass from the center of earth, and their radius is not equal to the radius of the earth, and the center of these circles is not the same as the center of the earth. So that was the concept of a great circle and a small circle. Any doubts up to here, beta? Very good, beta. Great. Go ahead, Shantmanu.
Sir, accidentally did it. I was putting the reaction on.
Oh, okay, no issues. Thanks. Bye-bye. Let's go ahead. Now we move on to the concept of a spherical triangle. We are familiar with plane triangles. We use them very often in our calculations. Now we are going to understand what is a spherical triangle. We have the diagram on the screen. A spherical triangle is a triangle on the surface of a sphere formed by the intersection of three great circles. Now, as you can see in this particular diagram, we have a triangle being formed on the surface of a sphere. This is a 3D diagram, and you can see this triangle being formed A, B, C. Now this triangle is being formed on the surface of a sphere. That's number one requirement for a spherical triangle. And second, all the three sides of this triangle, you can see side AB, it is an arc of a great circle. The second side BC is also an arc of a great circle, and the third side AC is also an arc of a great circles. All the three sides of the triangle should be the arcs of great circles. So that's a mandatory condition to be fulfilled for a spherical triangle. If any one of the sides is not the part of a great circle, or you can say if any one of the sides is the part or arc of a small circle, in that case the triangle is not a spherical triangle. For a triangle to be called a spherical triangle, it is mandatory that all the three sides should be the arcs of great circles only. Now in a triangle there are total 6 components. There are 3 angles and 3 sides. In plane geometry, the angles are measured in degrees, whereas the sides are measured in units of length, that is meters, centimeters, millimeters, etc. But in spherical triangle, there is a difference, a significant difference. All these 6 parts, that is the 3 angles of the spherical triangle, like in this case angle A, B and C, as well as the 3 sides of the spherical triangle. You can see these 3 sides, AB, it is also represented as small c, then BC, It can also be represented as small a, and the third side AC, which can also be represented as small b. The side is either represented by the vertices which connect to form that side, like for this particular side we can call it as AC, or you can also call it the small letter of the angle opposite to it. Now the angle opposite to this side is angle B. So you can also represent this side with small letter b. So in a spherical triangle, all these 6 parts, that is the 3 angles as well as the 3 sides, are measured in units of angles only. We do not measure the sides of the spherical triangle in units of length. They are all measured as angles. Now a doubt can arise in your mind that it is understood that angles are measured in angular units. So we can measure angle A, B and C in the angular units of degrees and minutes. But how do we measure the side of a spherical triangle in degrees and minutes? Now to understand that, for easy understanding, the magnitude of the side of a spherical triangle is basically the angle subtended by it at the center of the sphere. So let's take for example side AB. You can see this is side AB. Now if I join A with the center of the sphere here, and I join B with the center of the sphere, now both these lines joining A and B with the center of the sphere make an angle at the center. Now this angle is basically the measurement of this particular side of the spherical triangle. So repeating again, the magnitude of the side of a spherical triangle is the angle subtended by it at the center of the sphere. Any doubts up to here, beta? Great, beta. Very good. Now we have understood the basics of spherical trigonometry, the great circle, the small circle, as well as the spherical triangle. With this understanding, we are now ready to go into our first very important formula in spherical trigonometry, that is the cosine formula. The cosine formula is very, very important. It is used in solving great circle sailing problems, and it is also used in celestial navigation for solving rational horizon diagram based questions and the questions which are based on the PZX triangle. So let's understand the cosine formula. Let's have a spherical triangle on our screen. You can see a spherical triangle PAB, Papa Alpha Bravo. We have this spherical triangle. All 3 sides of this spherical triangle are arcs of great circles. Now the cosine formula says that cos of any angle of the spherical triangle is equal to cos of opposite side minus cos of adjacent side 1 multiplied by cos of adjacent side 2 whole divided by sine of adjacent side 1 multiplied by sine of adjacent side 2. Now what are these opposite sides and adjacent sides used in the formula? Let us try to understand by taking example of an angle in this triangle. We can take any one of these angles. Let us consider angle P for our understanding. Now if you have a look at angle P of this triangle, you will see that this angle P is formed by two sides of the triangle. One side is the green color side, Papa Alpha, and the second side is the blue color side, Papa Bravo. These sides which are involved in making this particular angle are known as the adjacent sides to this angle. And the third side, the red color side, AB, which is not involved in making this angle in any way, is known as the opposite side. So once the adjacent and opposite sides are clear, now we can see the application of the cosine formula. Let us apply it for angle P itself. The cosine formula says cos of any angle, in our case cos of angle P, is equal to cos of opposite side. Opposite side in this case is side AB, the red color side, minus cos of adjacent side 1, the adjacent side 1, Papa Alpha, multiplied by cos of adjacent side 2, that is Papa Bravo, whole divided by sine of adjacent side 1, sine of Papa Alpha, multiplied by sine of adjacent side 2, that is Papa Bravo. Now in this formula on the left hand side, we can have any angle of this triangle. We can have angle Papa, angle Alpha, or angle Bravo. And if you look carefully, on the right hand side of this formula, we have all the sides. One side is opposite, two sides are adjacent to any one of the angles. And in the right hand side, all the terms are involving the sides of the triangle. So this gives us a very good understanding that if we know all the three sides of a spherical triangle, we can use the cosine formula to calculate any of the angles of the spherical triangle. Any doubts in the cosine formula, beta?
No, sir.
Great, beta. Very good. Let's now try to understand the usage of the cosine formula. What are the situations, what are the scenarios in which cosine formula can be used? We have the spherical triangle PAB on the screen. Now cosine formula can be used in two situations or in two conditions. The first one is when all the three sides of the spherical triangle are known to us. When we know all the three sides of the spherical triangle, we can calculate all the remaining part, that is all the three angles of the spherical triangle. We have seen in the formula that on the right hand side, we have all the sides of the triangle. So putting these sides, any of the angles or all of the angles can be calculated. The second situation or second scenario in which this can be used is when we know any two sides of the spherical triangle and the included angle. Now it is important to note that we need to know the included angle of the sides. Let us take an example. Let us assume that we know side Papa Alpha, that is the green color side of the triangle, and Papa Bravo, that is the blue color side of the triangle. Now what is the included angle? Included angle means the angle made by these two sides. So in this case, angle Papa is made by sides Papa Alpha and Papa Bravo. So if we know side Papa Alpha, side Papa Bravo, and angle P, which is the included angle, we will be able to calculate all the remaining parts of the spherical triangle. In our first application of the formula, we will be able to calculate the opposite side, which is side AB. And once the opposite side is calculated, we will be able to calculate angle A and angle B also. It should be kept in mind that we need to know the included angle of the two sides which are known. If you know any other angle other than the included angle, like you know side papa alpha, you know side papa bravo, and you know angle A. Angle A is not the included angle now. In this case, cosine formula will not be applicable. Now a doubt may arise, what is to be done in these situations where included angle is not known but some other angle is known? So that is not required as of now. We will see the solution when we come to those type of questions. Any doubts up to here, beta? Great, beta. Very good. We now
Sir,
move into our...
sir,
go ahead, beta.
if two sides and one included angle known, so the formula will be the same, cos theta equal to cos opposite minus cos adjacent 1 by
Yeah,
sine.
that's correct, beta. The formula will remain the same. Even if you know two sides and the included angle, put these values in the same formula and you will be able to calculate the remaining sides.
Okay, sir.
Okay. We now move into our second very important formula in spherical trigonometry, which is the Napier's rules. Now these Napier's rules are applicable to special spherical triangle. Now what should be the speciality of the spherical triangle? The speciality should be that any one of the parts, that is any one of the sides or any one of the angles, should be 90 degrees. So if any one of the part of a spherical triangle is 90 degrees, the Napier's rule can be used in that spherical triangle. Now you can see this spherical triangle Papa Alpha Bravo, and in this spherical triangle, the side AB, the red color side, is a 90-degree side. The 90-degree side is shown by making a rectangle like this on that particular side of the triangle. And if a side is 90 degrees, that triangle is known as a quadrantal spherical triangle or a right-sided spherical triangle. So this is one situation in which the Napier's rule can be used. The second scenario in which Napier rule can be used is on a triangle having a 90-degree angle or a right angle. Like you can see in this particular triangle, Papa Alpha Bravo, you can see angle Bravo. There is a rectangle or there is a square made on angle Bravo, representing or showing that this angle is a right angle or a 90-degree angle. So this is the second situation in which a Napier rule can be used. Moving ahead now.
सर ये रेक्टेंगल वाले में डाउट था सर.
Go ahead, beta.
What is that, sir? Rectangle जो बना हुआ है, that is the side AB is 90 degree.
Exactly, beta. If you see this kind of a rectangle made on any side of the spherical triangle, this indicates that that particular side is a 90-degree side. Okay, beta?
Okay,
Clear?
sir, understood. Wonderful.
Okay, all right. We are now going to understand the application of the Napier's rule for a right-angled triangle. A triangle having a 90-degree angle. Now you can see the PAB triangle, Papa Alpha Bravo triangle, and we can see in this particular triangle that angle B, angle Bravo of this particular triangle is a right angle or a 90-degree angle. Let's now see how the Napier's rule is applied to a right-angled triangle. Now to apply the Napier's rule, have to first make a circular diagram. This circular diagram is known as a cartwheel. So for making this diagram, first of all, we draw a circle. Then we make a cross in that circle. You can see the cross coming up on the screen. And after the cross is made, from the center, we draw a vertical line in this particular way. Now, when you do this, this divides the circle into 5 different parts. We can see the cartwheel or the circle divided in 5 different parts. Now, in the bottom 3 parts, the bigger parts of the cartwheel, we fill up the terms 90 degrees minus, 90 degrees minus, 90 degrees minus. So all the 3 bottom parts of the cartwheel, we have filled up the term 90 degrees minus. Now we identify the 90 degree part of our triangle. In this case, the 90 degree part is angle B, angle Bravo. This 90 degree part is written on top of the cartwheel. So you can see angle Bravo coming on top of the cartwheel. Now from this 90 degree part, that is angle Bravo of our triangle, we starts to move clockwise in the triangle. So from angle B, we move in a clockwise direction. You can follow the laser pointer moving in the clockwise direction. And you will see that if you move clockwise from angle B, the next part of the triangle which comes is the side AB, Alpha Bravo. So likewise in the cartwheel, from angle B, we move in the clockwise direction. And the first part which comes here in the cartwheel, we fill up this particular part AB. So you can see AB being filled up. Now moving further clockwise, the next part after AB which comes is angle A. Moving further in the cartwheel, the next part which comes is this particular part. Now in this part, we have already filled up 90 degrees minus, and after this term, we fill up angle A here. So the part becomes 90 degree minus A. Coming back to the diagram, after angle A, if we move clockwise, the next part is the green color side, Papa Alpha. Moving further in the cartwheel, we come to the bottom part. We have already filled up 90 degree minus here. And after this, we filled up the part Papa Alpha. So the bottom part of the cartwheel becomes 90 degrees minus Papa Alpha. Coming back to the triangle, after Papa Alpha, the next part which comes is angle P. In the cartwheel, the next part which comes is 90 degree minus P. Moving further, the next part of the triangle is side Papa Bravo. And moving further in the cartwheel, the next part is filled up as Papa Bravo. After Papa Bravo, we come back to the right angle Bravo. And similarly in the cartwheel, after filling up Papa Bravo, we reach up to the 90 degree part which is Bravo. So we move clockwise in the triangle. Whatever parts come up, they are filled up in the cartwheel. In the cartwheel also we are moving clockwise and the cartwheel is filled up now. We have now learned how to fill up the cartwheel. Now we go into the Napier's formula. The Napier's formulas, there are 2 Napier formula. The first one is on the screen. Sine of the middle part is equal to tangent adjacent part 1 multiplied by tangent adjacent part 2.
Sir, 1 minute.
The second formula is sine of the middle part is equal to cos opposite part 1 multiplied by cos opposite part 2. Go ahead, beta. Go ahead.
Sir, I have filled going on the triangle going anti-clockwise and filling the circle on clockwise. Is it okay? Because
Yeah, that's fine. That's fine. That's fine, beta.
then the first one I starts with PB, 90 minus P, 90 minus PA, 90 minus A, AB.
Perfectly all right.
Okay, sir.
your answer will come. Whether you go clockwise or anti-clockwise, both ways the answer will come. मैं अभी explain भी करूँगा आगे.
Okay.
Okay. Now we will be using the cartwheel as well as these two formulas to apply the Napier rule to this particular triangle. Now what is the use of this Napier's rule? In a special spherical triangle, if you know any two parts of the triangle other than the 90-degree part, any two parts of the triangle are known to us other than the 90-degree part. The known parts could be two sides, the known part could be two angles, or the known parts could be one angle and one side. So if any of the two parts of the special spherical triangle are known to us other than the 90-degree part, using the Napier's rule, we can find out all the remaining unknown parts of that particular triangle. I will repeat once again. In a special spherical triangle, if we know any two parts of the triangle other than the 90-degree part, using Napier's rule, we can find all the other unknown parts of that triangle. Now, we have used adjacent parts, middle part, and opposite parts in the formula. A doubt may arise in your mind that how these parts are named. We will understand these parts when we go to the application of the Napier rule. Now, before we proceed to the application, a couple of things more. To easily remember the formula, you can see on the left-hand side of the formula, we have sine of the middle part. In both the formulas, the left-hand side is sine of the middle part. Now, on the right-hand side, you see that tangent and adjacent, they always go together. Now you see tangent and adjacent are rhyming words. So wherever we have adjacent parts available to us, we will be using the tangent formula. And if you see in the second formula, cos and opposite, they always go together. Cos and opposite both have the sound of O. So if opposite parts are available in a particular triangle, we will be using the cos formula. So always remember tangent and adjacent, they go together. Cos and opposite, they go together. This makes it very easy to remember the formula and not make any mistake in application. Second important thing, you may have a doubt that in case instead of going clockwise in the triangle, somebody follows a anti-clockwise motion. He goes anti-clockwise in the triangle and he goes anti-clockwise in the cartwheel also. Now, if you go anti-clockwise in the triangle and you go anti-clockwise in the cartwheel, even then the application of the Napier's rule is going to be correct. Also, if somebody goes clockwise in the triangle and he goes anti-clockwise in the cartwheel, one of the places he goes clockwise, another place he goes anti-clockwise, even then the application of the Napier's rule is going to be correct and accurate. Any doubts up to here, beta? Great, beta. Very good. Let's see its application now. Let's now see the application of the Napier's rule for a right-angled triangle. Now we have a right-angled triangle PAB here on the screen, and we have also filled up the cartwheel for this particular triangle. If we know any two parts of the triangle other than the 90-degree part, using the Napier's rule, we can find any other part of the triangle. So let's assume that we know two parts in this particular triangle. Let's assume that we know side PA, Papa Alpha. For the purpose of the example and our understanding, we know side Papa Alpha. I have shown it with a green tick mark, and we know angle P of this triangle. Again, I have shown this with a green color tick mark. Now using these two and the Napier's rule, we can find out any other part of this triangle. But let's assume that first of all, we need to find angle A of this triangle. Let's put a question mark at angle A, indicating that this is the part which needs to be found out. Now, first of all, we need to identify these three parts. Two parts which are known to us and the third part which we want to calculate. We have to identify these three parts in the cartwheel. So let's identify the three parts. We know side papa alpha. The side papa alpha is in this part of the cartwheel. So we put a tick mark here, green color tick mark, indicating that this part is known. The next part which is known is angle P. So angle P is here in the cartwheel. So let's put a tick mark here also, indicating that angle P is known to us. And the part which we want to find is angle A. Angle A is in this part of the cartwheel. So let's put a question mark here, indicating that this part is to be calculated. Now we can see the three parts, two known and one unknown, in our cartwheel. Now out of these three parts, one of the parts has to be identified or taken as the middle part. Now when we are choosing or picking up a middle part, we need to be careful that the remaining two parts should either both be adjacent part or the remaining two parts should both be opposite parts. It should not happen that we pick up a middle part and out of the remaining two, one of them becomes adjacent and another one becomes opposite. Both of them should either be adjacent parts or both of them should be opposite parts. Now why is that so? That is so because if you see our Napier formula, in the formula we have either both the adjacent parts or we have both the opposite parts. We do not have a formula involving one adjacent and one opposite. Now what are these adjacent and opposite parts? If you consider any part in the cartwheel, let's consider this part 90 minus PA, you will see that two of the parts are having a common side with this part. 90 minus P has a common side with 90 minus PA. Similarly, 90 minus A has a common side with 90 minus PA. The parts which are having a common side with the selected part are known as the adjacent parts. And there are two parts which do not have a common side with 90 minus PA. These are parts PB, Papa Bravo, and AB, Alpha Bravo. PB and AV do not share any side with the part 90 minus PA, which we selected in the first place. Now these parts which do not share any side with the selected part are known as opposite parts. So out of these three, we need to select one particular part as our middle part so that the remaining two becomes both opposite or both adjacent. Now if somebody picks up 90 minus A as his middle part, then you see 90 minus PA will become adjacent to it and 90 minus P will become opposite to it. So we will not be able to apply the formula. If somebody picks 90 minus P as the middle part, 90 minus A will become opposite and 90 minus PA would become adjacent. Again, we will not be able to apply the Napier formula. If you pick 90 minus PA, 90 minus Papa Alpha as your middle part, then the remaining two parts, 90 minus P and 90 minus A, both become adjacent parts and we can use the adjacent formula. So 90 minus PA becomes our middle part. So we apply the adjacent part formula, which is sine of the middle part is equal to tangent adjacent part 1 multiplied by tangent adjacent part 2. Middle part is 90 minus PA. So sine of 90 minus PA is equal to tangent of adjacent part 1, which is 90 minus P, into tangent of adjacent part 2, which is 90 minus A. Now in this relationship, 90 minus PA term is known to us. 90 minus P is again known to us, both indicated in the green color. The only unknown here is the term 90 minus A. So using the scientific calculator, we can easily calculate the 90 minus A part and find out our answer. Any doubts up to here, beta, in this application?
No, sir.
No, sir.
Very good, beta. Great. याद आ गया सब?
Yes, sir.
Yes, sir.
Okay, great. Let's move ahead. Let's now see the application of the Napier's rule for a 90-degree side spherical triangle or a quadrantal spherical triangle. We can see the triangle PAB having a 90-degree side AB. Let's first make the cartwheel. The cartwheel is made exactly in the same way. You see a circle, a cross, a vertical line, dividing the cartwheel into 5 different parts. In the bottom 3 parts, we write the terms 90 minus, 90 minus, and minus 90. Now the only difference in the application of Napier rule for a right-sided triangle is that in the bottom part of the cartwheel, instead of writing 90 minus, we write minus 90. This 90 degrees, which was in the beginning of the term for a right angle triangle, now comes to the end of the term for a right-sided triangle. The part of the triangle will come in front and this 90 degree goes to the back. This is the only difference between application of Napier rule for a 90 degree side triangle. Now we can fill up the cartwheel. On top of the cartwheel, we write the 90 degree part, which is side AB in our case. Moving clockwise, the next part which comes is AB. The next part which comes is angle A. We fill up angle A here. The next part is side Papa Alpha. 90 minus was written earlier, so we fill up Papa Alpha here, and this part becomes 90 minus PA. The next part is angle P. Moving clockwise after Papa Alpha, next part is angle P. So you can see now angle P comes in the beginning, comes in the front. And the bottom part of the cartwheel now becomes P minus 90. This is the only difference in the application for a 90 degree side triangle. Moving further from angle Papa, the next part is side Papa Bravo. So the part becomes 90 minus Papa Bravo. The next part is angle B. Angle B is also filled up in the cartwheel and the cartwheel is completed. The formulas which are used remain exactly the same. Sine of middle part is equal to tangent adjacent part 1 multiplied by tangent adjacent part 2. And the second formula, sine of the middle part is equal to cos opposite part 1 multiplied by cos opposite part 2. So the only difference which we see is in filling up the bottom part. Remaining everything exactly remains the same as we did in a right angled triangle. Any doubts in this, beta?
No, sir.
Very good, beta. Great.
So this also triangle we can go anti-clockwise and circle we can go clockwise.
Yes, beta, certainly. You can go clockwise or anti-clockwise, any direction of your choice. You can go clockwise in the triangle, anti-clockwise in the circle, or you can go anti-clockwise in the triangle and clockwise in the circle. All will work.
Okay.
Okay, great.
Sir, I have some doubt. Why you taking the P minus 90, sir? Why not you taking the 90 minus P, sir?
Okay, beta, this is the formula, so we can't do anything.
Okay.
So this you have to memorize, and this is there in the formula. इसका proof derive किया जा सकता है, but no need to do that. We don't need the proof.
Okay.
Okay.
Sir, one side will be 90 degrees. So when you take the clockwise, so when you come to the P, so P minus 90. That's correct, sir? In making
What is your doubt, beta? Say again once.
I doubt is the P minus 90. Yes, I have only one doubt is the P minus 90. But last formula drive, so there is mentioned is 90 minus P. But now this one A and B is 90 degree. So you have to change here to P minus 90. That's I have little bit confused.
Okay. Beta, see the bottom part here has to be part minus 90. So 90
Yes.
will come in the end. So whenever you
Yes.
see a 90-degree side triangle, always remember
Yeah.
that in the bottom part of the cartwheel, 90 will go to the end. It will not come in the beginning.
Yes, sir. Okay.
Okay. So memorize
Understood, sir.
this
Yes, sir. Yes, sir.
and apply. Right, beta.
Thank you, sir. Yes, thank you, sir.
Right. We can now see the application of Napier's rule for a 90-degree side triangle. If we know any two parts of the triangle other than the 90-degree part using Napier rule, we can find any other part of the triangle. So for the purpose of our example, let us assume that we know side Papa alpha. We have shown that with a green tick mark, and we know angle P. And we are now trying to find out angle Bravo of this particular triangle. So let's identify these parts in the cartwheel. The side Papa alpha is in this part of the cartwheel. So let's put a green tick mark here. Angle P is in the bottom part of the cartwheel. You see the green tick mark coming here. And angle B is in this part of the cartwheel. You can follow the laser pointer. So angle B is shown with a question mark. Now if we make P minus 90 as our middle part, 90 minus PA is adjacent and angle B is opposite. So that does not fulfill our requirement. If we make 90 minus PA as our middle part, P minus 90 becomes adjacent and angle Bravo is again a opposite part. Again, this does not fulfill our requirement. If we make angle B, angle Bravo as our middle part, 90 minus PA and P minus 90 both become opposite parts. So now we can apply the Napier's formula here. The middle part in our case is angle B. So Napier formula says sine of middle part is equal to cos opposite part 1 multiplied by cos opposite part 2. So middle part is B, that tells us sine of P is equal to cos of opposite part 1, which is 90 minus PA, multiplied by cos opposite part 2, which is P minus 90. 90 minus PA and P minus 90 both are known to us. So putting these values and using the scientific calculator, we can easily calculate the value of angle B. Any doubts in this application, beta? Great, beta. Very good. So I'm closing down the presentation now. Okay, great. So all remembered, beta? Yaad aa gaya sab? What you did earlier? The Napier's rule, the cosine formula, what is the application? How do we apply them? Everything clear?
Yes, sir. Yes, sir.
Okay, beta. Great.
One question. Sir, in
Go
the
ahead.
cosine formula, you said all three sides known, we can find all three angles, right? Same
No,
way.
no, beta. No. Either you should know all the three sides of the triangle, that is one scenario in which cosine formula can be used, or you know two sides and the included angle, side
Yes.
angle side. Okay.
Only-
With three angles cosine formula cannot be applied. वो मैं आपको बाद में बताऊंगा. I will tell you later how to go with three angles.
Okay, sir.
Okay. Okay. Great, beta. Very good. So with the Napier rules and cosine formula clear in our mind, now we are ready to jump into the great circle sailing. But let's take a short 5 minutes break, beta. We take a quick 5 minutes break, get your tea, coffee mugs refilled, and come back after 5 minutes. Okay?
Okay, sir.
Okay, beta. Yeah, beta, are we back?
Yes, sir.
Yes, sir.
Okay, all right, beta. Great. Okay, so let me put up the presentation. Now we go into the great circle sailing, and let's apply what we have learned in spherical trigonometry to a great circle sailing problem. So let's go. A basic great circle sailing problem will basically give us two positions on the earth surface. You are at position A, you want to go to position B. They will tell you to calculate the great circle distance between those two positions and the courses, initial course and final course. So this is what we are going to see now. We will use these concepts which we have learned. Let's go. We have now understood the basics of spherical trigonometry, the cosine formula, and Napier's rule. With this knowledge and understanding, we can now easily solve a great circle sailing problem. Now, in a basic great circle sailing problem, we are given our initial and final positions. Two positions are given to us, and we need to calculate and find out the great circle distance between those two positions. And we also need to find out the initial and final courses. When the vessel moves on a great circle track, the course of the ship continuously keeps on changing. So it will be different at the location of the initial position where we depart, and the course is going to be different when we arrive at our destination. Now we can easily understand this kind of a problem using a diagram. So let's make a simple diagram of the earth. You can see the earth shown in this particular diagram. We have the equator and we have the poles. We have the North Pole as well as the South Pole. Now let's assume that our initial position was at this particular location where you can see alphabet A coming up. This is our initial position. Let's assume for the sake of example, in our question, the initial position is given to be 30 degrees north and 020 degrees east. Now let's assume that the final position is given to us as B Bravo, and this is 40 degrees north and 070 degrees east. Now after we have shown initial position A in our diagram, we now need to make a rough diagram showing the position Bravo, our destination position. We can see from the latitudes that position B is north of A. That is why we have shown position B higher than position A. And also we can see that position Bravo or position B is east of position A. Position A was at 020 degrees east. Position B is 070 degrees east. That's why we have made this position B to the right side of A, showing that it is east of A. The location of these positions with respect to each other should be accurate. So we need to be familiar with calculating the d lat and d long between positions. Now let us draw the meridian of both these positions. You can see the meridian of A coming up. This meridian cuts the equator at this particular point. Let's name this point as C, Charlie. Let's now show the meridian of our destination. You can see the meridian going from North Pole, our destination position B, and going up to the South Pole. This meridian of our destination position cuts the equator at this particular point. Let's call this position as delta. Now let's join A to B with a great circle track. We need to find out the distance, great circle distance between A to B. So basically this is what we need to find out, the track A to B. Now you pay your attention to the arc A to C, alpha to Charlie. This is the arc of the meridian contained between the equator and position A. And if you look closely, this is the definition of the latitude. So arc of the meridian contained between the equator and position of A is the latitude of A. Also, we are aware that from the pole, if we go along the meridian to any point on the equator, this total arc is 90 degrees. So from Papa, the North Pole, up to the Charlie point, which is on the equator, is total 90 degrees. Alpha to Charlie is equal to the latitude of our initial position A. This tells us that Papa to Alpha, P to A, will be equal to 90 minus latitude of A. This is also known as colat of A. Now exactly in the same way, if you have a look at our destination position, arc of the meridian between equator and our destination position, that is Bravo to Delta, is equal to the latitude of our destination. Papa to Delta is 90 degrees, pole to equator 90 degrees. Therefore, Papa to Bravo, the blue color track which you see, is equal to 90 minus latitude of B. This is also known as colat of B or complementary latitude of B. Now let's take our attention to angle P of the triangle, angle P. Now if you look at this angle P, this is the angle at the pole contained between meridian of A and the meridian of position B. This is the definition of D long, difference of longitude. Difference of longitude between A and B is the angle at the pole contained between meridian of A and meridian of B. So we can mark this angle as the D long from A to B. Now if you look at this triangle Papa Alpha Bravo, which is made on the surface of Earth. Now this triangle is made on a sphere. The Earth is a sphere, and all the three sides of this triangle are great circles. Papa Alpha is the arc of a meridian. All meridians are great circle. Papa Bravo is again the arc of a meridian. All meridians are great circle. And Alpha to Bravo is a great circle track. That is what we are trying to find out. So Alpha to Bravo is certainly a great circle. So triangle PAB is made on the surface of a sphere, all three sides of which are parts of great circle. So this is a spherical triangle. And in this spherical triangle, we are given the initial and final positions. So we can find out what is the colat of position A or side Papa Alpha. This will be known to us. We also have the latitude of position B, so we can easily find out what is the colat of position B or 90 minus latitude of B, that is side Papa Bravo of this triangle. And we will also have the longitudes of initial and final position A and B. That gives us the D long between the two positions A and B. So if you look closely, we know two sides and the included angle of this spherical triangle. And we are aware that when we know two sides and the included angle, we can solve the spherical triangle using the cosine formula. So this is what we are going to do now. We are going to apply the cosine formula to triangle PAB.
Sir, excuse me, sir.
Go ahead, beta. Go ahead.
सर वो एंगल एट द पोल डी लॉन्ग ए माइनस पी थोड़ा वो प्लीज एक्सप्लेन कर देना फिर से.
Okay, ये A minus P नहीं है बेटा. It is the D long between A and B. The definition of D long definition is Angle at the pole contained between the meridian of two places. And this is exactly angle P of our triangle PAB also. That is why this angle P is the D long between A and B.
Okay, sir. Understood, sir.
Okay, great.
Thank you, sir.
और doubts बताओ बेटा. Go ahead with your doubts.
नहीं सर वही डाउट था सर इसको क्या. थैंक यू सर.
Very good, beta. Great. So, great, beta. We have seen the PAB triangle, and let's now apply the cosine formula to this triangle. Let's go. Let's now apply the cosine formula to triangle PAB. We are aware PAB is a spherical triangle, and in this spherical triangle, two sides and an included angle is known to us. So we apply the cosine formula to angle P. The cosine formula gives us the relationship cos of angle P is equal to cos of opposite side, which is AB, minus cos of adjacent side 1, which is PA Papa Alpha, multiplied by cos of adjacent side 2, which is PB Papa Bravo, whole divided by sine of adjacent side 1 PA, multiplied by sine of adjacent side 2, which is PB. We are aware or we know angle P, which is the D long between A and B. This is known to us. We also know Papa Alpha, which is the colat of A. We know Papa Bravo, which is the colat of B. So using all these terms which are known to us, indicated in green in the formula, we use this relationship. Using our scientific calculator, we can easily obtain the value of AB, Alpha Bravo. This is the only unknown in the equation. So using the scientific calculator, we obtain AB. Now this side AB, which we obtain, gives us our great circle distance. Now when we calculate this side AB using the scientific calculator, the calculator is going to give us the answer in degrees and minutes or decimal of a minute. Now when we want to have the great circle distance, we need to convert this value into minutes, because 1 minute of this arc of the great circle on the surface of Earth is equal to 1 nautical mile. So to get the distance in nautical mile, we will have to convert the value which we obtain from our calculator in degrees and minutes to minutes. To give you an example, if we get this side AB as 30 degrees and 12 minutes, the calculator is going to give us the answer in this particular format. We need to convert it to minutes. So 30 degrees multiplied by 60 plus 12 gives us the total number of minutes. That is 1812 minutes of this arc. This 1812 is our great circle distance in nautical miles. Whenever we do any calculations using the cosine formula in the PAB triangle, we always use the degree and minute format. That is, for in our example, 30 degree 12 minute format. And when we want to give our answer for great circle distance, we convert this into minutes, and that will be our answer for GC distance in nautical miles. Any doubts in this, beta?
Excuse me, sir.
Go ahead, beta. Go ahead.
This cos AB we will find out. To find out cos AB, we will transfer sin PA and sin PB to that side and divide by cos P will be cos PB. Is it how that we will find out?
Yeah, that's correct, beta. You will take the terms which are known to the left-hand side. So sin PA, sin PB, which is in the denominator, will be multiplied with cos P. And the cos PA, cos PB term, which is subtracted here, will be added on the left-hand side. Okay, beta, understood?
Copy, sir.
Okay, all right. Great, beta. So that was the calculation of great circle distance. Let's move ahead. We have now obtained the great circle distance between the two positions. The next thing which we need to calculate are our initial and final courses. Now the initial and final courses are obtained from angle A and angle B of this triangle PAB. In this triangle PAB, now we have all the three sides available to us. PA and PB were already known to us. They were colat of A and colat of B. And the third side, AB, has been calculated. With these three sides available to us, we can now use the cosine formula and we can calculate angle A and angle B of our triangle. So for calculating angle A, cos of angle A is equal to cos of opposite side, which is PB, minus cos of adjacent side 1, PA, multiplied by cos of adjacent side 2, AB, whole divided by sine of adjacent side 1, PA, multiplied by sine of adjacent side 2, AB. All the sides are known to us. So on the right hand side, all the terms are in green. Putting all these values using our scientific calculator, we can get the value of angle A. Exactly in the same way, angle B is obtained. Cos of B is equal to cos of PA, which is the opposite side, minus cos of PB, adjacent side, into cos of AB, adjacent side, whole divided by sine of PB multiplied by sine of AB. So using the cosine formula, we can find out angle B. All the terms on the right hand side are the sides which are known to us. Once we obtain these two angles, angle A and angle B, they will help us to find out our initial and final courses. Important thing to remember is that these angles are not our courses. These are the angles of the spherical triangle PAB, and we will need to use these angles to find out or get our courses. In some cases, fortunately, the angle may be equal to the course, and in a other situation, the angle may not be equal to the course. So let us now see, using these two angles, how do we obtain the initial and final courses. Any doubts up to here, beta?
No, sir.
No, sir.
Very good, beta. Great.
Hello, sir.
Yeah, go ahead.
Actually, I have one doubt, sir. Little off topic. If
Mhm.
you, sir, considering this is a spherical triangle, sir, which is complying with the uh, GC. Which is in which we can apply the this cosine formula rule, sir. Suppose this angle, the angle subtended on North Pole, sir, is 90 degrees, or the angle is 90 degrees.
Right,
And instead of applying the Napier's rule, if we apply the cosine formula rule,
right.
will the answer will be same, sir?
It will still be correct, beta.
The answer will be same with the cosine and both and the Napier both, sir.
Yes, that's correct, beta. Basically, your question is, your doubt is that in all the situations where Napier rule is applicable, can we apply the cosine formula also? The answer
Yeah,
is
right, sir.
yes.
Right, sir.
You can apply the cosine formula also there. The steps will increase, but you will get the correct answer.
Okay, sir. Thank you.
Okay. Napier's rules are basically derived from the cosine formula itself. They are a shortened form of the cosine formula. So wherever Napier rule is applicable, cosine formula can also be applied. However, we do not do it because there is no use. It makes the calculation lengthier. So that's why we always prefer to apply the Napier there.
Okay, sir. Copy that. Thank you.
Okay. Now we are going to use a very simple method to find our initial and final courses. Let's first make the PAB triangle here. We do not need to make the full earth diagram now. We can only show the PAB triangle. So you can see the PAB triangle coming up on the screen. We have the PAB triangle. Our shape is going from A to B. Now for calculating the courses, the first step is to make a rough diagram of the shape at our initial position and our final position. You can see the rough diagram of the ship coming up at our initial position A. Let's make the rough diagram at our final position B also. Now the course of a ship is basically the angle between true north and the ship's head measured clockwise. So we are going to use this definition to obtain our courses. I will repeat once again. The course of a ship is the angle between true north and the ship's head measured clockwise. The method which we are using is going to give us the course in 3-figure notation or 360-degree notation or true notation. The courses can also be denoted in quadrantal notation, but with this method we are going to obtain them in 3-figure notation. And if you need them in the quadrantal notation, they can be easily converted to quadrantal notation later on. So we are using a very simple 1, 2, 3 method involving 3 steps to get our courses. First of all, we need to identify the north direction. When the ship is at position A, the north direction is basically given by the meridian. The meridian runs north-south, and the direction in which the meridian goes towards the North Pole gives us the northerly direction at any location. So we can show the meridian as the north direction here for our location at position A. The direction of the meridian going towards the North Pole gives us the northerly direction. The same thing is applicable at B also. The direction of the meridian going towards the North Pole gives us the northerly direction. So we denote the north direction by alphabet November N. This is the first step. We identify and start from north. This north is our reference point to get our courses. Now from this north point, we go in the clockwise direction and we go up to the ship's head. You can see this blue color arrow starting from north, going clockwise, going up to the ship's head. We obtain this as an angle and this gives us our initial course in 3-figure notation. Now fortunately, this blue color arc and angle going from north, going clockwise up to the ship's head is exactly same as angle A of our PAB triangle. So fortunately in this case, our initial course is equal to angle A of the PAB triangle. Let's do the same thing at location B at our destination position. We start from north, we go clockwise and we go up to the ship's head. Now this angle which we have obtained, the blue color arc and the angle, starting from north, going clockwise, going up to the ship's head, this gives us our final course. And you can now see that our final course is not the same as angle B of the PAB triangle. Angle B which we obtained using cosine formula was the inner angle of this triangle, and the course angle is the outer angle of this triangle. So initial course is equal to the angle A of our triangle, and for the final course, if we measure a total angle at any point on the great circle track, this total angle is 180 degrees. Just like straight lines, if you measure an angle at any point, we measure this angle at point Bravo from the direction of the stern of the ship to the direction of the bow of the ship. This total angle is 180 degrees. We know the inner angle B from cosine formula. So 180 minus inner angle B gives us the outer angle B, which is our final course. So you can see the final course is equal to 180 minus B. The course will be obtained in three-figure notation or true notation using this method.
Excuse me, sir.
Go ahead, beta.
Sir, I understand the things this one, but I get sometime confused for this. You said course will be always measured from meridian, correct? In case of any either initial course or final course.
Three-figure notation course,
So
beta. It will be measured from the north.
north or meridian. So
Yes.
for this, we need to measure from means track. You said if we measure from track, then is 180. So subtract from these angles. This figure, these things. Can you explain one more time, or maybe clear my doubts, sir, regarding this?
So basically your doubt is about the final course.
Final course direction like this. If we go on when to measure from meridian or when to measure from the track of the vessels, so
Okay.
it should be correct. Which should be the
Okay.
correct method, sir?
Okay, beta. Okay.
Or
Now your first question is, when should we measure the course from the meridian and when from the GC track? Okay. The answer is course is always measured from the north direction in the meridian. Always. The course will be measured from the north direction of the meridian. Always, in all the cases. So that is why you see final course में जो angle हमने बनाया है बेटा, it is starting from the north direction and going clockwise up to the ship's head. Okay, the course will be measured up to the ship's head, not up to the great circle track, up to the ship's head.
okay, sir.
Getting clear, beta?
Yes, sir.
Okay, very good, great.
Yes,
और कोई doubt है बताओ?
Sir, but why 180
सर
minus?
अगर हम लोग साउथ पोल में होंगे सर.
Okay, one by one. So first doubt is why 180 minus B? Okay, as simple as that, beta. We have calculated angle B of the triangle PAB. So what angle we have obtained is angle Papa Bravo Alpha. But what angle we require is not Papa Bravo Alpha. Papa Bravo Alpha is representing the inner angle of the triangle. What we require is the angle Papa Bravo up to the head of the ship. So that is why 180 minus B. Does it
Okay,
make
sir.
sense? Clear?
Yes, sir. Sir, sometimes for measuring this final course or any course, we also subtract this from 360-degree also. So, if possible, can we see the conditions when to
Okay,
subtract from
all right.
360 or when to subtract from 180 or any some thumb rule is there, or by figure we can
Okay,
understand the things. If you give some
okay,
time
beta.
here, so it will help a lot, sir.
Okay, I got your doubt, beta. So what are the situations where this course angle will be 360 minus angle of the triangle? So I will show you those situations, beta. मैं आपको practical situations दिखाता हूँ. So we will see that. अभी मैं examples आपको दिखाता हूँ आगे. Another doubt was, what if we have the south hemisphere and the south pole is there? वो example भी दिखाता हूँ बेटा. I will show you some more examples where it will become clear. Thumb rule in this case is only one. This 1 to 3 method which you see on the left hand side. Identify and start from north, go clockwise, go up to the ship's head. Follow this in all the situations and you will get the course angle. So let me show you a few more scenarios to make it clear. Let's see that. Let's now see another example for making this concept crystal clear in our mind. This time we take the ship on a westerly course. you can see the PAB triangle coming up on the screen. Our initial position is at A in this case. We are going in this particular direction shown by the arrow, and our destination is at position B here. So the vessel is moving on a westerly direction great circle track. Now we first need to make a rough diagram of the ship. You see the rough diagram coming up at A, and we have the rough diagram of the ship coming at B. Then we follow our method. First of all, we identify the north direction. So the direction of the meridian going towards the North Pole gives us the northerly direction. We represent it by alphabet N. Same thing is done at Bravo. Direction of the meridian going towards the North Pole represents the north direction. We represent this by alphabet N. Now, starting from alphabet N, pay your attention to the initial position. We go clockwise from the north direction and we go up to the ship's head. So you can see this blue color arc and arrow coming up from the north direction, going clockwise, going up to the ship's head. This is our initial course. We had calculated the inner angle A of our PAB triangle, and we can clearly see that the course in this case is going to be 360 minus angle A. The total angle starting from north going clockwise and back to north is 360 degrees. The inner angle A was obtained earlier. So 360 degrees minus inner angle A gives us the outer angle A from the north direction going clockwise up to the ship's head. This is our initial course. Clear, beta? Understood?
Yes, sir.
Very good, beta. Great. Let's come to the final position now. Starting from north, going clockwise, going up to the ship's head. This arc and arrow shows the final course in three-figure notation. Now we know from the north direction up to this point here, this is the inner angle B of the triangle, which we had calculated using the cosine formula. And from the stern of the ship up to the bow of the ship, this is total 180 degrees. So this tells us that our final course is 180 plus B. You can see the final course coming here. 180 plus B in three-figure notation will be our final course.
Thank you very much, sir, for explaining these things, sir. One more thing I need to ask regarding this figure.
Go ahead.
In formula, when we are calculating, we are getting always the value inside the triangle, correct? Like angle
Yes.
B. Yes. And then
That's
our
right.
actual course is 360-degree notation. So we are
Yes.
adding 180 and plus that whatever value we are getting.
We are doing this 1, 2, 3 beta. Starting from north,
Yes.
going clockwise, going up to the ship's head. And for that, if
Okay.
it is required to add 180, we do that. For that, if it is
Yes, sir.
required to subtract the angle from 360, we do that.
Good. Okay, sir. Thank you very much, sir.
Okay. Let me show you one more example now. So और clear हो जाएगा बेटा.
Sir, can you repeat one time more,
Let-
sir? Because my internet was disconnected, so I can't understand and I didn't see the figure, sir. So can you repeat one more, sir?
Okay beta. Okay. Here is the figure beta. Here is the figure. And you can see we have followed exactly the same method 1, 2, 3. Starting from north, going clockwise, going up to the ship's head. So have a good look at the diagram बेटा. अगर इसमें doubt आ रहा है तो मुझे बताओ. Clear है बेटा? Getting clear?
Yes, sir. Yes, sir. Yes. Yes, sir.
Okay, all right. मैं अभी explain करूँगा. I'll explain it more in the southern hemisphere also, so it'll get revised. Let's take one more example to make it clear in our mind. Now this time let's assume the ship is in the southern hemisphere. So when we make the PAB triangle, we will have to take the reference from the south pole. When the ship is in southern hemisphere, the triangle PAB is made with reference to the south pole. Initial position is at A, ship is moving in this particular direction and going up to position B. So let's make the rough diagram of the ship at our initial position A. Let's make the rough diagram at position B. Now we follow our 1, 2, 3 method. Identify and start from north. The direction of the meridian going towards the north pole gives us the northerly direction. So this is the south pole at the bottom. North pole will be upwards. So we mark this alphabet N indicating the north direction. Likewise, at location B, we see the direction of the meridian going towards the north pole and we mark this as alphabet N indicating the north direction. Now at our initial position A, we start from north going clockwise and we go up to the ship's head. So starting from north, going clockwise, we go up to the ship's head. This blue color arc and arrow gives us the initial course of the ship. You can see now from the north direction going clockwise up to the south direction is 180 degrees, and this inner angle of the triangle which has been calculated is angle A. So the initial course of the ship is given by 180 plus angle A. Clear, beta? Understood? Very good. Let's go to the final course position now, position B. Starting from north, going clockwise, going up to the ship's head. You see this particular angle shown by the blue color arc and arrow is our final course.
360 minus.
Now, as we have two straight lines intersecting, the opposite angles are equal. Exactly in the same way, when two great circles intersect, the opposite angles are the equal. So this inner angle B is going to be equal to this outer angle B here. The opposite angles generated when two great circles intersect with each other are equal. So from the north point, if you go a complete round back up to north, this is 360 degrees. This angle is equal to angle B of the triangle. So 360 minus this angle B gives us our final course. The final course is given by 360 minus B. So we have seen the calculation of courses in different scenarios: northern hemisphere, southern hemisphere, easterly courses, and westerly courses. Any doubts, beta?
No, sir.
Very good, beta. Great. Very good. Let us now recap what we have done. Let's give a recap. Now, one important thing which should be kept in mind while solving these great circle questions is that when we are making the PAB triangle, the position A and B should be shown in the correct orientation with respect to each other. What do we mean by this? Let us understand using this example. We have an initial position 50 degrees north and 040 degrees east. That is our first position A. And our destination position, final position, is position Bravo 45 degrees north and 005 degrees east. We want to make a PAB triangle for this. Now both these positions are in the northern hemisphere, so we pick up the north pole for making our PAB triangle. So let's show the north pole in our diagram here. Now let us mark our initial position A. Let's assume that our initial position A is at this particular location. We can take it at any position of our choice. So this is our initial position A. Now when we are marking our final position B, you can observe from the latitude that B is southwards of A. A is at 50 degrees north, whereas Bravo position is at 45 degrees north. So B has to be slightly south of A. And the second thing which we note from the longitude is that position B has to be west of A. A's longitude is 040 degrees east. B's longitude is 005 degrees east. So it has to be west of A. So with respect to position A, I go slightly southwards and westwards. This is where we need to make our destination position B. So the position A and B are now in the correct orientation with respect to each other based on their D lat and D long. Now we can draw the PAB triangle. You can see the meridians of A and B coming up, and now the great circle track also coming up, and the PAB triangle is made. Now instead of making the triangle like this, if you put this position B onto the right side of A or to the east of A at this particular location. If somebody puts position Bravo at this particular location and makes the triangle like this, this would become wrong because the orientation of Bravo is not correct with respect to position A. As per the D long, position Bravo is to be west of position A, but in our diagram, if you make B at this particular location where the laser pointer is right now, it will be at a wrong orientation because the diagram is showing Bravo east of A. So this would be a wrong representation in the diagram. The diagram on the left side is the correct PAB triangle, and this point should be kept in mind. If we make the wrong triangle, all our answers will become wrong. Any doubts, beta?
No, sir. Thank you.
Very good, beta. Great. So just one recap more. Before proceeding further, let's have a recap of the steps which we discussed in solving a great circle sailing question. Now the first step involves plotting the destination position Bravo with respect to the initial position or the departure position alpha. This will be based on the difference of latitude and the difference of longitude from the initial position to the final position. So you need to be very careful, you need to be clear about the concept of how to get the D lat between two positions and how to get the D long between two positions. The name of the D lat and the name of the D long will give you an idea about the location of your final position with respect to the initial position A. Now, locating the final position is very, very important because if the triangle is not made in the correct orientation, the answers which you will be getting will be wrong. So the correct orientation is a must. So you please be clear about how to calculate the D lat and how to calculate the D long between any two positions. Now, once B is plotted with respect to A, we have to select the appropriate pole of our triangle. Now, how do we select the pole? If both the positions are in the same hemisphere, north hemisphere or south hemisphere, then whichever hemisphere the positions are, the pole which is selected is also of the same hemisphere. If both our positions are in the north hemisphere, we will be picking up the north pole for our PAB triangle. Now, in case the positions are not in the same hemisphere, you are going from one hemisphere to another. In that case, whichever hemisphere has the higher latitude out of the initial and final position, whichever hemisphere has the higher latitude, that pole is used for making the PAB triangle.
Excuse me, sir. Sir, if I'm going 1 degree north to 1 degree south, then which pole I will select?
Now, in case the initial and final latitude is exactly same, both are having exactly same value, in that case, any pole of your choice can be taken. Let's say, for example, you started from 20 degree north and you are going up to 20 degrees south. Both the latitudes are exactly same. You can pick up a pole of your choice. Now, most of the candidates are comfortable with picking up the north pole. That gives you a better looking triangle. So you can pick up the north pole in that case and solve the PAB triangle.
Okay, sir.
Excuse me, sir. Hello.
Go ahead, beta. Go ahead.
Yes, sir. As you said, like if we are going to if we are sailing from one hemisphere to another hemisphere, so in any hemisphere which has a higher latitude, we have to take that hemisphere's pole, right?
Yes,
So
that's right.
I mean to ask is, even if we take the other pole, I mean, if we do the reverse, vice versa of that thing, no, if we are going, if we have the higher latitude in southern pole and we are taking the northern pole, so I think that should be okay for the calculation purposes, as we are using cosine and sine, and I mean, it should also give the same, should give the right answer,
Got your
right?
doubt, beta. Got your doubt. Now, mathematically, yes. Even if you pick up the other pole, you will still be getting a accurate answer. Only thing is the calculation may become little more tricky because your sides and angles will keep on getting bigger and bigger. And the more sides and more angles are bigger than 90, there will be more confusion and doubts when you are taking sine theta, cos theta, and tan theta. So
Okay,
the
sir.
angles ratios are going to become negative. So it may make the calculation a little tricky, but yes, mathematically you can get the answer.
Okay, sir. Okay, sir.
Okay. So it is recommended to pick up the pole where the higher latitude is. That will keep the triangle small and the calculation easy.
Okay, sir. I'm asking this because sometimes we can make these kind of mistakes. So I was just wanted to be aware that if we are making this kind of mistakes, whether our answer will be right or wrong, sir. That's it.
It'll still be right, beta, if you do it mathematically correct.
Okay, sir. Thank you.
If possible,
Okay.
sir, if possible, this different hemisphere diagram is there. If possible, it's possible to see, sir, how it's coming, sir.
Okay, beta, I'll show you. Just let me finish this. I'll show
Yes,
you.
sure. Okay, sir. Thank you.
Now, once the pole is selected, A and B are plotted correctly, the PAB spherical triangle can now be drawn. Once you draw the PAB spherical triangle, you have to apply the cosine formula. When we apply the cosine formula, the first thing which we obtain is the great circle distance between the two positions. And once the distance is obtained, a second application of the cosine formula gives us the initial course, and a third application gives us the final course, which can be calculated by obtaining angle A and angle B of our PAB triangle. So these are the steps involved in solving a basic great circle sailing problem. Okay, now let me show you a diagram where you are changing the hemisphere. Give me a minute. Okay, all right. So let's make the earth. We show the equator here. Let's assume our initial position is here in the northern hemisphere. Let's mark it as A. And let's assume our final position is in the southern hemisphere. So that's somewhere here. That is position B. So we want to make the PAB triangle. First we ascertain higher latitude. Now in this case, you can see A has the higher latitude. So we pick up the North Pole. We pick up the pole where the higher latitude is. So this is the pole which we pick up. Now let's draw the meridian of A. So I draw the meridian of A going up to here. If you want, you can extend it further also. If you want, you can stop it here at A. Let's mark the meridian of B. So this is the meridian of B. And now let us show the great circle track. So this is how the great circle track is going to be, something like this. This is going to be our PAB triangle, beta. Papa Alpha Bravo. Clear, beta?
Okay, sir. Thank you. And then in this case, PV value should be more than 90, correct, sir? 90
Yes, it will be 90 plus latitude of B.
Yeah.
Right, beta? Clear?
Okay, sir.
Very good, beta. Great. So I'm closing this down now. Great. So this was the target for today, to complete a basic great circle problem. So now tell me, beta, how did the class go? Were you able to catch on what I was trying to make you understand? What was the speed? How did you find? Were you able to understand it well? Any problems you faced? Give me a little bit of feedback.
Perfectly close, sir. Within one class, great circle, all doubts will be cleared, sir. No more doubt required in here, sir, like initial, final course and all these things. Perfectly clear, sir. No doubts. Thank you.
ओके बेटा, ग्रेट, वेरी गुड. सो बेटा अब मैं आपको एक आपके व्हाट्सएप ग्रुप पे आई विल सेंड यू वन वीडियो ऑन ग्रेट सर्कल सेलिंग. जो चीज़ मैंने आपको आज करवाई है वो उस वीडियो में भी होगी. सो यू कैन, इफ़ यू वांट, यू कैन वॉच इट अगेन. एंड उसी वीडियो में आपको 3 सॉल्व्ड एग्जांपल्स मिलेंगी. सो प्लीज़ वर्कआउट दोज 3 सॉल्व्ड एग्जांपल्स. Work out those 3 solved examples. After those 3 examples, you can go to Great Circle Sailing exercise in the practical navigation book. Great Circle Sailing exercise in the practical navigation book and practice the questions there. Okay. So practice the basic questions only, where initial course, final course and distance is required. So this much practice you do. Now tomorrow's class, I will be showing you the concepts related to vertex and intermediate positions. So these are advanced problems in GC sailing. So vertex and intermediate positions we will be covering tomorrow. Right,
Sir, one more thing. Yes, sir. One more thing, sir. Whatever topic we covered today, and whatever video you will share, this will be also available for future if possible, or you will give some notes or something like a
Okay. Beta, wherever required, I will keep on giving you the notes. Like for today, the important things which we did. Cosine formula, Napier rule, their application. ये मैं आपको एक note भेज दूंगा. So you will have that with you. And videos I am telling you initially, सारे topics के videos available नहीं है बेटा. सारे topics के videos available नहीं है. Whatever topic videos are available, वो मैं आपके साथ share कर दूंगा. Okay? Otherwise, अगर बाकी के टॉपिक्स में आपको कोई डाउट आता है, द व्हाट्सएप ग्रुप विल रिमेन एक्टिव. सो ड्यूरिंग द क्लासेस यू कैन ऑब्वियसली आस्क मी, and even after the classes are over, the WhatsApp group is going to remain active till your exams. So any doubts coming in those topics whose videos are not there, you can directly ask me on the WhatsApp group.
Okay, sir. Thank you very much, sir.
Okay. Great, beta. Excellent. So we are done for today. Anything else you want to ask or share?
Sir, which
Nothing.
exercise we will done sir today, sir? Which exercise we will do, sir? Because my
Beta,
internet
3
is
solved examples in the video which I am going to send you, and practical navigation book, Great Circle Sailing basic questions.
yes, sir.
Okay.
Yes, sir.
Okay, sir.
Okay. All right, beta. See you in tomorrow's class then. Bye bye.
Thank you, sir.
Thanks.
Thank you, sir.
Thank you.
Thanks, beta. Bye bye.
Yes,
Thanks.
sir, good night.
So
Good
tomorrow
night, beta.
9:30 class morning.
Morning class with Vishnu sir. Evening class I'll have as per the schedule.
Okay, sir. Okay, sir. Thank you.
Okay, beta. Great. Bye bye.